Okay, we'll talk through one way to solve this problem. If you graph this curve right here, you actually get this red hyperbola, which is opening up or down. And we want to find the point on, or points on that hyperbola that are the shortest distance from the point 5, 0. So here's the point 5, 0. And what we can do is let this represent any point on the parabola, because if we solve this for y, we get plus or minus the square root of 70 plus 4x squared. So any point on this upper branch, if we have a coordinate, an abscissa or an x-coordinate that's represented by the letter x, and the y-coordinate will be the square root of 70 plus 4x squared. Down here it'll be similar, but it'll be minus the square root of 70 plus 4x squared. Okay, now what we want to do is come up with a function that represents the distance between that point and 5, 0. So there's our 2 points. How do you find the distance between 2 points? You use the distance formula, which is the square root of the difference between the x-coordinates squared, so x minus 5 squared, and the difference between the y plus the difference between the y-coordinates squared. So you could picture a minus 0 in here if you wanted to, but after you square it, we just get 70 plus 4x squared. So now if we take the derivative of this function, picturing this radical raised to the 1/2 power, or this function as raised to the 1/2 power instead of using the radical symbol, we'll move the 1/2 down front. Here's the expression inside the radical, or inside the parentheses. Reduce the exponent by 1 to minus 1/2, then multiply by the derivative of the inside. Now, you could have expanded this binomial, combined similar terms, or you could take the derivative term by term. So the derivative of x minus 5, the quantity squared, 2 times x minus 5. The derivative of this is 8x. Notice that this 2 divides into both terms of the numerator. So we get x minus 5 plus 4x, which is 5x minus 5 over this radical. Okay. And now when does this equal 0? Well, it only equals 0 when the numerator equals 0. And that's when 5x minus 5 equals 0 or x equals 1. Okay, now you could apply the first derivative test. There's a critical number. And then choose numbers in each interval to the left of 1, to the right of 1, to see whether we get a maximum or minimum value. I guess if you picture putting 0 in the first derivative, you get a negative number. So this function is decreasing. And then to the right of 1, like if you put a 2 in, you get a positive number. So 1 generates a relative minimum for this function right here. Okay, and so if you put 1 in for x, y squared equals 74. Y equals the square root of 74. That's what this decimal is right here. And if you go to Desmos, I'll provide a link and slide this point around the curve. You'll see that the distance is greater than the distance to this point right here. Actually, this is the square root of 74 right here. Okay, so 1 comma square root of 74 and 1 comma minus the square root of 74 are the points on the curve that are closest to 5, 0. There you go. Hope that helped. If you have any questions, post a comment.